Today we want to talk about graphing exponential functions. We talked about exponential equations the other day. Exponential functions we simply replace with a y equals some number to an exponent. As a matter of fact, we'll look at it a little bit more specifically in kind of a more generic sense today. We'll take a look at y equals a times b to the x minus h plus k as a function. So we'll take a look at this guy as a function. B will define if we are dealing with decay or whether we are dealing with growth. And it will do that by what type of value it is. If we look at exponential growth, we are talking about that b value being greater than 1. If it is greater than 1, then you are dealing with something that is growing. That means as we go further from as x continues to get more positive, or as x continues to the right, our values are going to get bigger or smaller, okay? Keep in mind they can grow in a negative fashion, okay? Whether they're going to go up or down is based on the a value, okay? Our a value is that number out in front potentially, okay? That's what's going to cause it to go up or down. A will being positive will make it go up, a being negative will make it go down. But you'll notice in both cases, if b is positive, and you can see by the notation on the graph, these are 2 to the x and negative 2 to the x. The negative is what flips it over, but that's an a value. Otherwise, we got a 1 and a negative 1 for our a, and 2 is our b value. It is definitely bigger than 1. Likewise, if we're dealing with exponential decay, we're talking about something that's going to get smaller as time goes on, or as x continues to the right. Okay. In order for that to happen, basically b needs to be a fraction between 0 and 1, or it's got to be bigger than 0 but less than 1. We don't want b to ever be negative. That's a recipe for disaster, to be honest with you. And the question is, well, is it going to come from something that's up high and come closer down to a horizontal asymptote, or is it going to start down low and come up to a horizontal asymptote? And that, once again, is based on whether a is positive or negative. Now, let's take a look at these three graphs. You can see that all of them, as we go off, in this case, to the left, these are all exponential growth. It would be the opposite if it were exponential decay. They all approach a particular line. In this case, the line y equals 4 for the red one. As we do that, we'll notice that there's a relationship there. If we look at the function values right over here, you can see in 2 to the x minus 3, you can see the minus 3 right here is really where this y equals negative 3 asymptote is going to happen. If we look at this blue function here, y equals 0 ends up being the asymptote that we see back here. This was a 2 to the x plus nothing. There's nothing there. That 1 is part of the graph. Don't let that fool you. Take a look at this red guy up here. We got 2 to the x plus 4, and y equals 4 is our asymptote. What does that tell us? That tells us that this k value is going to give us our asymptote. What else does it tell us? Well, it also tells us that if we look at these a little bit more closely, these are all going up. These were all growth, but they all had positive 1 as that a value in front. If a was 1 in each of these cases, that means we were going up from that point. So our range is also going to be based off that asymptote. If a is positive, then our range is going to be y is greater than k. If a is negative, then our range is going to be y is less than k. Function cannot actually ever hit that asymptote, okay? It might look like it in these graphs, that we have something getting very close to that x-axis and the blue line and that x-axis become one and the same. They're really not. They're infinitely close to one another, but they are not actually the same. Now I'd like to look for turning points with you. Now turning points might be a little bit misleading actually, because these graphs are technically always turning. But if we look right in here, we can kind of see that's where most of the action happens. All right, we look right here, we look right here, we can see that there is a general place where this curve is happening. Well, when does that happen? We're going to take a look at that exponent value. So if we look at our fundamental equation here, a b to the x minus h plus a k, it's that x minus h, whenever that equals 0, that's what we want to look for. So when we say look for the turning points, we're going to find that the x value of that turning point by setting that exponent. Keep in mind, we could even have a number in front, a coefficient to the x there. This would still work to find that turning point. Once you find the x value, plug it in to find the y value. Okay, plug it in to find the y value. All right, we have a couple of examples to go through. We're going to go through them a little bit quickly. We're starting to run out of time here. I want to keep this as short as possible. First question we're going to do is we're going to try and graph this function right here. And the first thing is this growth or is this decay? And we're looking right here at this 2. It is bigger than 1. We are talking about a growth, not a decay. So this thing's going to either get really big or get really small. I'm sorry, get really small, like infinitely negative. All right, our horizontal asymptote, well, that's simply going to be the point y equals 1. So if we put over here right across, I don't know if you can see that. Let's change the color. Let's get that guy. There's our y equals 1 line. Now, if we take a look at that, we can notice that we're going to either go up or down from that. Are we going to go up or are we going to go down? Well, up in front here, this guy is positive. There is a positive 1 in front of this whole thing, so y is going to be bigger than that horizontal asymptote. Now let's go take a look at that turning point. The turning point, remember, we're going to look at that exponent and we're going to find out when it is 0. And it's 0 when x is negative 1. We'll plug that value in then to our 2 to the negative 1 plus 1. Now we should, after you do these a couple of times, you realize that that exponent should always simplify to 0. And anything to the 0 power is a 1, so we really have a 1 plus a 1 or a 2. So we have the point negative 1, 2 on our graph, negative 1, 2, and we need to find probably a couple more points. If we want to find a couple more points, I'm going to start by looking at negative 1, 2, and I think from there I'm also going to look at 0, and I'm going to look at negative 2, and we'll see where that puts us. If I plug in a 0, you can plug it in on your own. Pause and plug it in real quick. I came up with a 3 for the 0, and I came up with a 3 halves for the negative 2. So we're going to plug those guys onto our graph, 0, 3, and negative 3 halves for the negative 2. Now these aren't necessarily separating themselves that much, so what I'm going to do is I'm going to take the time to put in one more point, and that's going to be a 1. Go ahead and pause real quick and plug in a 1, and I got out a 5. So if we plug in a 1, we get out a 5. Now we really start to see this turn happening, okay, as we have our function going along that asymptote and turning and going up from that point. It continues in both directions. When you're graphing like this, I would say a minimum of 3 points. One of them can be the turning point, but you can see adding that one more point on the growth side of that turning point, just that second point helps us really start to see that turn. All right, let's try another one here. Once again, growth or decay. This time we've got a number between 0 and 1. This is a decay. In other words, it's going to start up high or down low, and it's going to end up getting closer and closer to some value of our asymptote. Now, our asymptote might be in a different place, though, so please remember that. We've got to figure out where that is. As a matter of fact, let's do that right now. Our asymptote is going to be the line y equals negative 4. Negative 4. So 1, 2, 3, 4. Here's our asymptote. This is just what our function is going to go towards. Now remember, we're decaying, so it's going to get closer and closer to that asymptote as x gets bigger. It's not going to get further and further away. Range. Well, we know that range is going to be based on that asymptote. The question is, are the y values going to be bigger or are they going to be less? And remember to look at that, we're going to look at this number out in front. Which you don't see it, it's a positive 1. which means it's positive, and we are talking about y being greater than that. So everything's going to be above that horizontal asymptote. Let's look for that turning point. That turning point happens when x plus 2 is equal to 0, or when x is negative 2. Let's find the y value that goes with that. F of negative 2 is going to be a 1/3 to the 0, that's a third, 1/3 to the 0 power minus 4, or a 1 minus a 4, or negative 3. So we have the point negative 2, negative 3, and that's our turning point, if you will. Turning point of negative 2, negative 3. Now from there, we want to get another point. Let's go with negative 1, and you can plug that guy in, and let's plug in a negative 3. And you can pause and plug those guys in real quick. I'll do the same. Welcome back. I hope you paused. These are the points that I came up with. I came up with a negative 1, negative 3 and 2/3, and we're going to put that on. We're going to estimate that guy as best we can. We got a negative 3, negative 1. Now this is really starting to shape up. I can kind of see how this guy is turning and going along this asymptote here, off into positive x direction. As it goes off to the negative x direction, let's go ahead and just put in one more point real quick. If we put in one more point, a negative 4 for x, we'll get a 1/3 to the negative 4 plus 2 power minus a 4, or a 1/3 to the negative 2 power minus a 4, also known as a 3 squared minus a 4, a 9 minus a 4, it's a 5. So we got the point negative 4, 5, and that should be pretty good for completing our graph here. See if I can get it in the right spot. And you can kind of see how this thing is just going to grow as it goes in the negative direction, but really as it's going in the positive x direction, it's decaying. It's coming from something very large, coming down to a value of close to negative 4, y equals negative 4. This is our last example. We're going to go kind of quickly here. We got only a couple of minutes left that I can fit this in. Growth or decay, once again, we're between 0 and 1, so we are talking about something that is going to decay. Our horizontal asymptote, hopefully we're getting pretty good at this now, is just this number right out here. Our range is y compared to that number, and because it's a negative 2, it's going to be a less than, okay? Because it's a negative 2, it's going to be a less than. So we got our asymptote of 3. We'll draw that guy in. Everything's going to be below that line. We have the same turning point happening again, or at least the x value for it is once again a negative 2. If we plug in that f of negative 2, then we should end up with a negative 2 times a 1/2 all to the 0 power. I'm sorry, not all, the negative 2. Don't misunderstand me there. Anything to the 0 power is 1, so we have a negative 2 plus a 3, and that becomes a 1. So we got our negative 2, 1. That's kind of our turning point. That's where a lot of stuff is happening. Now let's find a couple more values. I'm going to say it's probably a good idea to find several here. So let's go with a negative 3, a negative 4, a negative 1, and why not throw in a 0 as well? Pause it, and I'll get right back to you. Alright, these are the values I got. You can see my work there. I'd take the time to pause this real quick and check my work against your work. That should get you to be able to check that out. I want to come back in just a second here and put these on our graph and see what we end up with. Alright, I think I only got about a minute left here, so I don't want to take too long on this, but you can start to see there's my 5 points. We really have a good feel for what this graph is going to look like. It's going to come in here, and I drew it a little above that asymptote. I shouldn't have. I should have kept it below it, but you get the idea. That's what my graph should look like. Be good if we had time, we'll label those points as well, but this is how we graph exponential functions. I would encourage you, once again, at least 3 points, but grab some more as needed. All right, I hope this helps.